Hello everyone, we are from AI Group Core. Now our project is about evaluating large language models trained on code. Coming to abstract, large-scale language model like GPT-3 can accurately create human-like prose thanks to advances in natural language processing. These models were trained on natural language content and may not perform well on code-related tasks. This research tests begin big language models trained on code for code-related text generation. Code snippets and natural language descriptions are used to train and test algorithms for code creation and summarization. Large language models trained on code may create code-related text and outperform. And recent improvements in natural language processing have led to the creation of large language models that can produce text that looks and sounds like it was written by a person. These models have been used successfully in a wide range of situations like translating languages, making chatbots, and completing text. But these models have been trained mostly on natural language text and may not do well on tasks that involve code. In software engineering and related fields, it is very important to be able to understand and write code related text. Software engineers have usually done coding and documentation by hand, which can take a long time and lead to mistakes. Large language models might be able to automate these tasks, which would make software engineering faster and better. Now, my friend Raja will explain about the motivation and significance of this.
Okay, thank you, Vasavi. So today I'm going to tell you about the motivation and significance. So the software engineering has historically dependent on manual coding and documenting processes, both of which can be both time demanding and prone to mistakes. More recently, automated coding and documentation tools have become more popular. Software development may be made much more productive and effective if it is possible to automatically produce text that is connected to the code being developed. Massive language models have shown extraordinary success in the generation of text that is human like. Nevertheless, the usefulness of these models in the generation of text connected to code is not well understood. So, coming to the significance, large language models have the potential to automatically generate code, which can make the process of making software much more efficient. For example, code generation can help reduce the time and effort needed for repetitive coding tasks. This allows the developers focus on more complex and creative parts of software engineering. Evaluating large language models that have been trained on code can help figure out how these models can be used to make code and improve their accuracy and speed. This can help cut down on the time and work needed to write documentation so developers can focus on more important parts of software engineering.
Now, Bona will explain about paper proposal explanation.
Yeah, while coming to the paper proposal explanation, evaluating large language models trained on code, the author suggests a methodical strategy for assessing the effectiveness of large language models when applied to the code related activities. The primary objective of this study is to evaluate large language models that are state of the art, such as GPT-2 and GPT-3. These models have been trained on a huge number of text data, which may include documentation and code snippets. The purpose of this study is to offer a collection of evaluation metrics and datasets for the purpose of assessing the performance of large language models on code related activities. These tasks includes code complication, code creation, code summarization, etc. The paper also suggests a set of tests to see how well large language models do at these tasks involving in the code. In these experiments, the large language models are trained and fine-tuned using code-related database, and their performance is measured using the proposed evaluation metric. In this paper, a new method for evaluating large language models on code-related tasks is proposed. This method is meant to solve some of the problems and work around some of the limitations of methods used in the past. These problems include the lack of standard evaluation metrics and datasets. The need of fine-tune large language models on code-related tasks, and the lack of variety in code-related tasks and datasets. The method proposed in this paper can help researchers and practitioners evaluate how well large language models do on code-related tasks in a more systematic and thorough way. The proposed evaluation metrics and datasets can be used to compare different large language models and fine-tune them for specific code-related tasks.
Now Teja will explain about the experimental setup and results.
So when it comes to the experiment setup and results, in the report, evaluation large language models trained on the code. So the performance of the GPT-2 and GPT-3, Roberta, and Code Beta on different tasks related to the code is measured. The experimental setup includes the fine tuning and large language models on three different code related datasets like CodeSearchNet, uh, Codex, Glue, and Konala. The CodeSearchNet dataset, which has lot of Python functions and their natural language descriptions, were used to fine tune the models for the code compilation and code generation tasks. These tasks were graded on the how hard they were and how well they are done. And their blue score, the preparation measures how well the model can guess the next token based on the previous tokens. The result of the accuracy measures how well the model can guess the right token. Blue scores is a measure of the how well the generated code matches the truth. The results of the evaluation shows the all four large language models did well on variety of tasks that has to be done with the code. GPT-3 and CodeBed did the best at the most of the code-related tasks, while Robota and GPT-2 did just a little bit worse. The performance of the models, on the other hand, changed depending on the task and the dataset. The report also gives a detailed analysis of each language model's strengths and weakness, pointing out how they are used to improve the tasks like generating code, summarizing code, and putting code in the groups. Overall, the report makes a valuable. Coming to the strengths and limits, will be continued by the Charan.
Hi. The report evaluating large language models trained on code gives the detailed analysis of the strengths and weaknesses of the four state of what large language models on different tasks related to the code. Coming to the GPT-2, its strengths are it did well at some tasks that had to do with the code, like completing the code and making a new code. It has a lot of parameters which lets it capture both the code and natural language descriptions of a complex patterns. Its limitations are it doesn't have the specific ways to handle the tasks that involve code, which can slow it down on some tasks. GPT-2 can make a code that it that it is correct in terms of syntax, but wrong in terms of meaning, which can lead to wrong results. In GPT-3, strengths are most of the code-related tasks evaluated in the report showed that GPT-3 did the best. GPT-3 has a lot of different settings and can do a lot of different things. Its limitations are it wasn't made to do the tasks related to code, so it might not be able to pick up patterns and structures that are unique to code. It can cost a lot of computing power to train and use ChatGPT-3. Oh. Roberta. Its strengths it did well at some tasks that had to do with the code, such as summarizing code. It has lot of different settings that can do lot of different things. Limitations of Roberta. It doesn't have specific ways to handle tasks that involve code, which can slow it down on some tasks. Roberta can be hard to train and to use because it takes lot of computing power. CodeBot. Its strengths it can do well on most of the tasks that had to do with the code and were tested for this report. CodeBot is made for the tasks that have to do with the code, and it has ways to record the patterns and structures that are unique to code. CodeButt has its limitations, like it is made for the tasks that have to do with the code, which can make it hard to handle the tasks that have nothing to do with the code. CodeButt can be hard to train and use because it takes a lot of computer power. Overall, the report shows the strengths and weaknesses of each large language model for different code-related tasks. It also gives researchers and developers who want to use these models for software engineering applications useful information about how to do so.
So
Conclusion will be continued by Vasvi.
coming to the conclusion, the intersection of large-scale language models and the code-related tasks presents a dynamic landscape with both promises and challenges. While advanced in natural language processing, exemplified, exemplified by models like GPT, have demonstrated remarkable proficiency in generating human-like prose, their primary training on natural language content may limit their performance in code-related endeavors. Recognizing the significance of code comprehension and generation in software engineering, this research investigates the adaptability of large language models, including GPT-2 and GPT-3, Roberta, and CodeButt, to code related text generation. GPT-2 showcases commendable performance in tasks related to code completion and generation. Its extensive parameterization allows it to capture intricate patterns within both code and natural language descriptions. However, limitations arise from a lack of specific mechanisms for code related tasks, leading to potential slowdowns and instances where syntactically correct but semantically inaccurate code is generated. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.